I would like to work on problem 5.87 on page 246 in your textbook. This problem is similar to a homework problem that I had a question on. It says in an acidic solution, permanganate ion reacts with a 10(2), and it makes a manganese 2 ion and 10(4). Now we're going to use the ion-electron method to balance this redox equation. And so the first thing we would do is divide this reaction into its half reactions. Inspecting the manganese part, I see that I have one of each, so those are balanced. So then I balance the the oxygens by adding 4 waters to the product side, and then I'll balance the hydrogens by adding 8 hydrogens. The next step is to make the net charge on both sides the same. Right now I have 7 plus. Remember, here's a plus and here's an 8, so that's 8 plus and a 1 minus. So 7 plus on the reactant side and 2 plus on the product side. So I will add 5 electrons, so the net on both sides is 2 plus. The next step will be to balance the second part. The 10s are balanced. There's no oxygen or hydrogen to balance, and to balance the charge I will add 2 electrons. Now in an acidic solution, the last step is to add them together. In order to do that, the electrons have to be the same. So I'll multiply the first half reaction by 2 to get 10 electrons, and the second half reaction by 5. I'll go ahead and rewrite those so we can see what it would be. So rewriting the first half reaction, remember to multiply the 2 all the way through. And then on the second one, multiply the 5 all the way through. And now you can add these two together, add both half reactions together, canceling anything that is the same on both sides, which in this case is just the electrons. Now because this is an acidic solution, then this part of the balancing is done, and this would be the answer to the letter A. I'm trying to completely write the equation, and they're very long, so the water is going to be down a little bit lower. So there's an acidic equation that we balanced. And so now let's take a look at letter B. For the second part of this equation, we have to use our balanced reaction. So here I have it written at the top of this page, and we have to answer how many milliliters of the potassium permanganate solution are needed to completely react with 40 milliliters of the 10(2) chloride. Okay, so the 10(2) chloride, we know we have 40 milliliters of the 10(2) chloride, and it's a 0.250 molar solution. So if I change the volume into liters, so instead of 40 milliliters, I wrote 0.0400 liters, and this is of 10 chloride. Now, let me back up here because I know something that your book's going to say. So what I know is that one mole of 10 chloride, 10(2) chloride, is going to be 1 mole of 10. And so it's a 1-to-1 equation. So if I have 40 milliliters which I'm changing to liters, of tin chloride solution. And then I know the concentration is 0.025 molar, so that's 0.250, whoops, sorry, I did it wrong, 250 moles in 1 liter. Now, how did I catch so quickly that I had set that up wrong? Because of the units, right? Because I need liters to cancel out with liters. So I caught quickly, even though I was just riding along, I caught quickly that that was wrong by looking at my units. So 0.400 times 0.250, I get that this is 0.0100 moles of tin chloride. Now I know up here I wrote that 1 mole of tin chloride is 1 mole of tin, so I can say 0.0100 moles of tin chloride times 1 mole of tin. Now you might know this in your head, so you wouldn't really have to write this, but I just want you to see that we can know with 0.0100 moles of tin chloride would also contain the same amount of the tin too. So now we know the moles of tin too, so now we can figure out the moles of the permanganate ion. Because if you reread the question, they want to know how many milliliters of the potassium permanganate solution. So I have to go from the tin solution to the permanganate solution. So I'll say 0.100 moles of the tin ion would react with, now using the ratio from the balanced equation, I have a 5 in front of the 10 and a 2 in front of the permanganate. So that's going to tell me if I multiply by 2 and divide by 5, then I get 0.00400 moles of MnO4 minus. So that's how many moles of MnO4 minus I would have. Now, I'm going to turn the page and rewrite that number. So I have 0.00400 moles of the permanganate ion. And I'm looking, though, for potassium permanganate. But I know that 1 mole of permanganate is in every mole of potassium permanganate. It's a 1-to-1 relationship. Whoops. So what that means is that I will have 0.00400 moles of potassium permanganate. Now, if I reread the problem, I know the concentration of the permanganate solution is 0.230 molar. That was given. So if I know the moles in the solution and the molarity, remember molarity equals moles times the volume. So if I know the moles of the solution and I know the concentration, then I can find the volume. So I'm going to set it up like a conversion factor. So if I have this many moles of permanganate, and I know the concentration is 0.230 moles per liter, I can divide by the molarity by putting the moles on the bottom and the liters on the top. It wants it in milliliters, so I'm just going to multiply by 1,000 right here. and this is going to give me the milliliter. So take 0.004, divide it by 0.230, and multiply by 1,000. And I get 17.39. So to three significant figures, it would take 17.4 milliliters of the potassium permanganate solution. So let's review again, because this takes a lot of thought process. So we were given the amount, I'm going to look back. We were given the amount of the volume of the tin and the concentration of the tin. So we could find the moles of the 10,2 chloride. So 1-to-1 relationship, so the moles of the 10,2 chloride also equaled the moles of tin. Once we knew the moles of tin, we could use the ratio to determine the moles of permanganate. Permanganate is also a 1-to-1 relationship, looking at the formula, with potassium permanganate. So if I have 0.004 moles of permanganate, then I would have 0.004 moles of potassium permanganate. Now I was given the concentration of potassium permanganate. So if I know the concentration and I know the moles, I'm able to calculate the volume. And so I ended up calculating the volume.